Today we're going to do a math lesson from the Good and the Beautiful Course Book 2. He is on lesson 81, and it happens to be a short lesson, which is going to be really handy for this video. But I will say normally it's like three or four pages. In real time, my 2-year-old doing a puzzle here, so it'll be a little like real life, noisy and crazy.
Is the lesson I'm on.
Oh, okay.
So it's really good because I don't like long math lessons.
Okay. Decide which format would you like to use today to write the date?
Number.
Okay, we've been doing a lot of the word format for August, so I think that's a good time to alternate. All right, just go ahead and copy the date onto your paper, and you can write your initials today since you wrote your full name correctly and don't need extra practice on that today. So while he's doing that, I can be working with her on this puzzle. My other child is playing, and my other student is only with us on Mondays and Wednesdays, and today's Thursday. So I am going to I have a copy of the table of contents I use as a bookmark in his math book, and so I each day check off what lesson we did, excuse me, and I write the date, 8/24. And so we're going to start the lesson as puzzle pieces are flying onto the floor. All right, ready? Multiplication part 3. Have the child skip count by 4s from 4 to 28 once or twice if needed. Have the child use the chart. Go ahead, Josiah, and say your skip counting tables, please.
4, 8, 12, 24.
Oop, you skipped 16.
4, 8, 12, 16.
Use your
20,
finger.
24, 28.
Okay, so now sit down and use your finger this time, and then you can be done with that
4,
part.
8, 12, 16, 20, 24, 28.
Good job. Okay, have the child subtract 100 from each number aloud. So go ahead and subtract 432 minus 100.
332.
Good. 3,102 minus 100.
2,120.
Okay, we had a couple errors. You subtracted 1,000 from the thousands place, and you also accidentally reversed this and made it 20. So go to the hundreds place, and if you take that 100 away, what would the new number be?
It would be 3,020. Okay,
so do we have a 20 here? What is that?
Oh, it's a 2.
Right. Okay, so 3,102. So now let's just cover up the 3. We have 102. Take away 100 from 102. What would you have left?
2.
Right. So now 3,002. 2. Good. Okay. Read that to me.
1,000 minus 100.
Good. And what would that be?
900.
Good. Ready? And my hand's going to be on the camera, so I usually check as I go, but I'm not going to do that. An array is a group of numbers or items arranged into rows and columns. Look at this array with grasshoppers. How many grasshoppers are in each row?
2, 4, 6, 8, 10, 12, 13. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
You're correct. There's 15 total, but that wasn't the question. I asked how many are in each row. Can you?
2, 4, 5. 5 in each row.
That's right. And how many rows are there?
3.
Good.
So that would be 5 plus 5 is 10, and then 5 more is 15.
Good. I like the way you did that. You made a friendly number by making 10 first. And then what about multiplication? Here's the example. What did they do to turn that a repeated addition into multiplication?
What?
So that's how you'd solve it using addition, 5 plus 5 plus 5. How would you represent that as a multiplication problem? What did they show you here?
3 times 5 equals 15.
Good. So 3 times 5 equals 15. They explain in the parentheses that's 3 rows of 5. Yes? What is it? Oh, lovely. She's scribbling on my table of contents. You want to scribble on the back? You might as well. Sweet little precious memories. Okay. So, so that means 3 rows. How many rows are there?
What?
Do you see the rows? The rows are like laying down on a bed. They go from left to right. Row, row, row. Okay, and these are columns. Column, 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 column. So we have 3 rows, and each row has 5 in it. And that's how we get 3 times 5. Okay, now you're going to try it on your own. They did it for you. We talked about it. Now you're going to do it. Okay, write the addition problem and multiplication problem shown by each array. Okay, Josiah, let's see if you can do this on your own. If not, I'll help you. All right, you got your pencil?
Look what happened to my other lizard.
Oh no, your lizard, did he die?
Yeah.
Oh, I'm so sorry. Okay, we've been catching a lot of lizards. I've got to buy a UV bulb and heat lamp so we can keep them longer. I think maybe, did we leave that one in the aquarium overnight by mistake and not release it yesterday? Is that what happened? Sorry guys, a little nature study in math. Okay, write the addition problem and multiplication problem shown by each array. So Josiah, can you make an addition problem for this by telling me how many are in each row?
All right. 2, 4, 6. 6 in each row, so that would be 6 plus 6 is 12.
Okay, can you write that how you just said it with an equal sign right there where it says addition problem, please? Go ahead and do that quickly for me.
Oh. This is so easy.
Okay, Grace, hold on. We are not going to draw with dry erase markers because it dries them out. And it's also not polite to draw on other people's papers. Why don't you go get a paper out of our scrap paper drawer over there, okay? Can you do that?
No, I only like that paper.
Okay, but you don't start your sentences with no and responding to mommy. Okay, so I'm sorry, but you can't use that paper because she's using it. Would you like to start your math? All right, Josiah, sorry about that. Okay, good job on your addition. So now how would we turn that into a multiplication problem? What's the pattern?
Hold on, I want to
First you say rows of how many? Yes.
Can I do this first? I'm almost done.
Okay, sure, since you already started while I was dealing with Sissy.
2 equals 12.
All right, so how did you know to put 6 first?
That's fine.
Because 6 plus 6 is 12 and 6 times 2
Okay.
means 6 2
So,
times, which and 6 plus 6 is 12, which means you need 6 plus 6 means 6 and 6 equals 12.
Oh, okay. All right, can you sit back down now? All right, thank you for standing on your stage and explaining that so well. The only thing is, Josiah, even though 6 times 2 is 12, they actually want you to write 2 first. You know why? Because you put the number of rows first and then the number of how many are in each row. So you can leave that because that's an alternate way to do it. But if you're representing this array, then you're actually going to write 2 times 6. So if you want just above that, write a 2 and then times and then 6 above it. And you don't even have to rewrite the equal sign. Just so we remember that I did show you that.
This is so easy. I don't even have to erase the whole problem. I just erased the 6 and 2 and then put the 6 here and 2 here.
All right, so I just want to, this is actually a good little teachable moment. Can I borrow your pencil, please? So to show 6 times 2, our array would look different. We'd flip this up, instead and have it vertical. Oh, I can't see it yet. I love your picture. Beautiful. Okay, so we would have, see how now we have 1, 2, 3, 4, 5, 6 rows of 2. There's 6 rows now when it's stacked on top of each other instead of just 2 rows of 6. Okay? All right, let's move on to the next one. Does that make sense, Josiah?
Not really. So it equals a totally different answer.
No, it's the same answer. Are there still 12 here? 12 here and 12 here? Like the circles I'm representing.
No, but look, 2 6 times. 2 times 6 is 2 6
2
times.
6 times. Actually, we should say it differently because that's confusing you. Instead of saying 2 6 times, we say 2 rows of 6. Okay, so is it 2 rows of 6? Yes. Now what about this? Is this 2 rows of 6 or 6 rows of 2?
6 rows of 2.
Right? 1 row, 2 row, 3 row, 4 row, 5 rows, 6 rows. And I circled my rows, and each row has 2 in it. Okay, makes sense? So when we flip it, even though it has the same answer, we draw it differently. It's a different situation.
Excuse me?
Yes.
Can I get some orange juice, please?
Sure. We don't normally drink juice, but sometimes at math, we will have special snacks or things to encourage him. He's doing pretty good today. You understand it enough to do this one by yourself?
Yes.
Oh, yay, the caterpillar made its chrysalis. Okay, we'll take a look at that in a second. All right, ready? So what addition problem could we make?
4, 8, 12.
Ooh, good idea.
20.
Ooh, that was cool. I didn't know you even would think to do that. Counting by fours and using your little chart. Perfect.
All right.
So
that would
four, it's not 20 though.
20.
It's not 20 though.
It is.
It's not. 4 times 4 is not. So try find four times, 4 circles.
4, 8, 12, 20.
You skipped 16, my love.
Oh.
And Mommy
4,
has my
8,
facts
12,
memorized.
16.
Okay, so it's 16, and that's nice, isn't it? So you don't have to count one by one. Okay, so how would you make an addition problem for that? You'd put this plus this plus this plus this, right? So how would you write that?
Yeah. So that would be 4 plus 4 plus 4 plus 4.
All right, go ahead and do it. Equals what? Do you remember what you figured out by counting by fours? Or by knowing that 4 plus 4 is what? What's 4 plus 4, Josiah? You're thinking about another way to solve it? Okay, I'll let you finish thinking.
Wait, I was just thinking about something else.
Focus. Okay, so do you want to count by fours again, or do you remember the answer?
Equals 16.
Good. What's another way you could have figured that out? Using doubles facts. What's doubles
could've
fact? Doop. 4 plus 4
I
is?
could have just did this again.
You could have skip counted to figure it out, but you could also do what? What's 4 plus 4 in a snap?
8.
And now you have 8, and this is also what?
8.
And 8 plus 8 is?
16.
There you go. Okay, so now we need to turn it into a multiplication problem.
That's so easy. All you have to do is 4.
4 rows of?
No, 4 times 4 equals 16.
That's right. Ready, set, go-y.
All right. Where am I? Here?
Right here. So now we're doing this array. An array is when you arrange pictures in rows and columns to show a multiplication.
6, 8, 10. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.
Whoa. Are you going to count one by one when you know that's 10? If that's 10, how many are in the next row? Are the rows all the same?
That would be. Wait. That's 10, that's 10, and that's 10.
Correct.
And 30.
Yep. Okay. So how would you write that as an addition problem?
10 plus 10 equals 30.
Good. Good. Now how would you show it as rows of
All right, got it.
Good.
10 times 3 equals 30. Wait, what do I keep putting a 1 there? 30.
That's a very good and true multiplication equation, Josiah. However, it does not match the array. Are there 10 rows of 3 or 3 rows of 10?
3 rows of 10.
Okay, so you don't have to rewrite it. You can underneath just write it flip-flopped. Well, this is a good teachable moment. So this is another moment where I can show you the opposite. You drew this. You said 10 rows of 3. All right, now you're ready to do your independent practice.
1,300.
All right, so there were some teachable moments that happened before I started filming again, kind of while I was cleaning up and tending to the others. And so Josiah was working on is remembering that, for example, here there's 3,000s and 0 and remembering to put a placeholder to put that 0 in the hundreds place. And then instead of writing 10 and then seeing there's a 4, just to go ahead and put the 10 and the 4 together and just see 14 and write 14. So he's got 1,300, and then we went ahead and put our 10s together and wrote out the 10s as 20. And now, so he's writing it in number form and expanded form. Do you want to show them how you do knuckle mnemonics? So to know how many days are in each month, we also have a poem that we use, but we're going to use knuckle.
April, May, June, July.
So how does it work?
So now it
Wanna
goes
show 'em?
31, 30, 31, 30.
Right. So, okay, so I'm going to use his as an example. So you would pretend that the high points of your knuckles and the middle parts is each a month. And if you say you start here with January, and if it's on a high point, it's 31, and the months that fall in between the knuckles are 30 days. So January, February, March, April, May, June, July, August, September, October, November, December. Now, February is the only one that, even though it falls between the knuckles, can you put your knuckles back here so I can use them, Josiah? Even though February, January, we know it's 31 because it's on the knuckle, but February falls between the knuckles. All the rest are 30 days if it falls between, but of course, February is always 29 days, unless it's a leap year that it's 28. There's also a fun poem. Do you want to say the poem for them, Josiah?
30 days, half September, April, June, and November. All the rest have 31, except in February alone, to which the 28 is signed. A leap year gives us 29.
Good. Okay, go ahead and do your problems on the bottom, and we will be done for today with math.
113. How do you write 113?
Okay, so you don't need a placeholder.
1,
Think you're-
13. 1, 1, 3.
And it might bring you comfort to see that, like, for example, if I say write 113 on a normal day, you would just write it, no problem. But sometimes when their brain is stretching and trying it in a new way, or if they've just done an activity like this where we're talking about 0 as a placeholder, it actually might throw them off for other things. And so we can see where when children are young and they're just still getting really solid with skills, there might be some, mistakes that happen, and even if they normally know it. Good. Excellent. All right, so put your bookmark in, which is the table of contents page that I need to recopy since, yeah, you saw the doodling my 2-year-old did on it when I wasn't looking.